Well, thank you everyone for coming to this CPP. A little bit different today. You know, we have a lot of talks about climate and data products, all kinds of things. And what I'd like to speak about today is, as the title says, reflections on COP26 from a climate scientist and geographer. It's a story about, well, in part about climate change, strongly about climate change, but also about geopolitics, and also a little bit, you might say, about the frailties of humanity. So going on from that, what's this all about? Now I've got to get that working. There we go. So what are these things, these COPs? Now we've got the 26th one I'm talking about, which means they've been going on for a while. Well, this was the 26th United Nations Climate Change Conference, or COP26, that was held in Glasgow, in Scotland, back this previous autumn. Now, what does this mean? This stands for the Conference of the Parties. This was the 197 nations that agreed to the United Nations Framework Convention on Climate Change way back in 1992, right, when things weren't really happening that much yet in terms of climate change. Now, there's a long history of these COPs. Okay, the COP21 was a big one. That was held in 2015. And that negotiated what was called the Paris Agreement. That was this global agreement to reduce greenhouse gas emissions. And what it had called for, this Paris Agreement, was net zero anthropogenic emissions by the second half of the 21st century, which we're creeping up on, and efforts to limit the global temperature increase to well below 2 degrees C. The idea being, if you stay below 2 degrees C, okay, we've got some warming, but we can manage it. We won't have really maybe big problems with sea level rise and things like that. Now, COP26, that's the one that just happened. The parties, that's the countries, were expected to strengthen commitments to meet a 1.5 degree C limit, so a lower limit, right, on the warming that we could really have before things get really bad. That's the idea. All nice and noble sounding. Now, here's the big hope, right? This is a graph of the global average temperature, that what we call the surface air temperature, measured at sites all around the world. This is the NASA analysis. Other like NOAA and other agencies have made their own sort of plots. They all look very, very, very similar to each other. But this is the one from NASA, which is just fine. And what it is showing in each of those little squares is the average temperature for that year. This goes back to 1880. This is going up through 2021. And you can see from year to year, there's all this variability, all these ups and downs associated with all kinds of what we call internal variability in the climate system. El Nino cycles, La Nina. We're in a La Nina right now, which tends to make things a little cooler. Volcanic eruptions like Mount Pinatubo are all involved in here. But what you see is that overall things are increasing, and the red line is just kind of a smoother on, just to kind of show the sort of broader change, the broader changes. And yeah, we're warming up. Now, the thing is, if you look at this, depending on what kind of statistical analysis you'd like to do, we're actually getting pretty close to that 1.5 degrees C already. I've heard the number 1.2 that we're at now. We're close. The point is that we're fairly close already, just where we are today, right? But yeah, the idea is to limit it, to limit the warming to 1.5 degrees by the year 2100. Well, can we do that? That's the question. Now, these COPs, they are, of course, extremely international, right? Countries from all over the world participating, 197 nations. And there's a lot of representation from universities and things like this, including the University of Colorado. Now, what happened is the University of Colorado selected some representatives to attend this COP26 in Glasgow as observers, right? As opposed to those who are taking actual part in the negotiation. There's observers, and then there's the negotiators and their staff. And the negotiations are those that lead to agreements on things like greenhouse gas emissions or the lack of agreements, depending on your point of view. Now, NSIDC has been coordinating with this NGO, non-governmental organization called the International Cryosphere Climate Initiative, or ICCI. And so they've been working with us, and they wanted CU to have a strong presence in something called the Cryosphere Pavilion, which was one of the many pavilions at COP26 from different countries, NGOs like ICCI, industry, and other groups as well. And 3 NSIDC representatives were selected by CU to attend and work with ICCI, and that was myself, right? And Walt Meier and Tuvalu, 3 of our scientists here. All right, so you might say, why the hell was I selected? Who the hell am I, right? So I am a professor here in the CU Department of Geography. So I teach courses on Arctic climate. I teach courses like this last semester on basically, Earth 101, things like that, how the planet works. Also a climate scientist, overall polar focus. I like the Arctic in particular, but have done work in a lot of different places as well. A bit of a science communicator. And also director of the National Snow and Ice Data Center, which is, of course, where I'm speaking from today, and a Ceres Fellow. Ceres is the big institute that NSIDC is a part of. Right? Now, I just put a couple of photographs here to try and get the idea that even as director of NSIDC, I'm not just an administrative paper pusher, right? I actually try to do things. So there's a photo from the field in 2021 in Alaska doing some permafrost work. I started doing Arctic field work way back in 1982, before anyone was really talking about climate change or certainly warming. As a science communicator, one of the things I did recently was write this book called Brave New Arctic, The Untold Story of the Melting North. I didn't choose the title. It was a little more, the publisher did, right? But they try to do it to sell books, but I haven't gotten rich yet, put it that way. So, any case. All right, so here's Glasgow. Right now, here's Glasgow. This is where the conference was held. Beautiful old city. We were there in November. And so when you're there in November in Glasgow, it's either rainy or it's dark or it's just dark, right? I mean, it's pretty far up there in latitude, although it's actually on the southern part of Scotland. It's a very old city. And the thing is, navigating a city like this is for me, anyhow, very, very difficult. So this is not like New York City or Denver or anything like that out on a grid network, right? Old cities like this in Europe are just roads going in all kinds of crazy directions and things like this. It's pretty difficult. So I found that the best way to navigate was actually by the church steeple. I knew if I had to get down to the convention center where this thing was going to be held, well, I was looking at that particular church steeple, and that's where I'd head. I found that even with your GPS and your iPhone, it was difficult because you're always going in circles and things like this. But I quickly found that you navigate by the church steeple. Okay, so here's where they put me off, right? Housing was clearly a premium at this venue because there were people coming in from all over the world. The delegates got all the good lodging. I was put up with others in the Glasgow Youth Hostel. And this is the accommodations that I had, pretty simple, right? A couple of bunk beds. It could have held 7 people. I was there just with one other guy. It was interesting. The other guy I got turns out to be, when I became director, right? This was back in the last century. No, not quite. But in any case, a long time ago, there was one other finalist, right, who I beat out. It turns out the other finalist was my roommate. So it was a little awkward, you might say it sometimes, but actually we got along pretty well because we both ended up doing fairly well in our careers. But yeah, this was it. And I'd never stayed in a youth hostel. I found out quickly they don't do things like supply soap or anything like that, right? So I had to go down to the little store and get all these sorts of things. But that's where I was. We managed. Now, getting to the venue was quite the ordeal at times because we were right in the middle of the pandemic. And there were these very, very strong COVID precautions, right? So, of course, I had to prove that I was vaccinated and boosted. So here's my CDC vaccination card. And we had to be tested daily for COVID-19. So we all got these kits that you pick up at one of the hotels. We're all pretty familiar with these sort of strips that you see on the lower left. Of course, one line, right, is good, right? So I was just on one line, right? You don't want two lines that says you caught COVID. And what they do, this is all self-administered. You pick up these kits and you have to test yourself every morning. And then you have to log into this website and plug in the code on each of these strips and then state that it was negative. So it was kind of, you were on your own. It was a honor system, you might say, to actually do it, but seems that pretty much everyone complied. There were all kinds of levels of security to get into what they called the blue zone at this convention center where all these pavilions were located. And once you got in, you got all these various kits. We all got, for example, our COP26 hygiene kit, which contained sanitizer and some masks and things like that. Now, I've still got my COP26 hygiene kit. I never opened it because there were plenty of masks around and things like that. And I've got it on my shelf because my thinking is that years from now, this may well be a collector's item. Right? So I've got it sitting right here in my office. But yeah, then once we got there, right, this was like the first or second day. I think Twyla took this particular picture, but it was just this sea of humanity. And these were basically all the observers. Okay, the delegates pretty much had been in there doing their thing. I think they probably had separate entrances or something. I'm not sure. But this is what it was. Now, fortunately, the lines kind of moved quickly, and there were people outside handing us muffins and things like that. But it was quite the thing just getting in. And then there were all these different levels of security once we got there. Now, so observers and delegates. Right? So I mentioned there were these two sort of categories. There were observers who were there to watch, right? And the delegates. So the observers, and that was me, Twyla, Walt, we had access to the blue zone, which was managed by the United Nations. It was considered to be UN territory during this conference. And this is where delegates, observers, the media, and others mixed in the pavilion era and the action center. And this is a shot of the action center here, where they had a big globe and things like that, and all kinds of tables set up so you could go there and hobnob and network with people. But the real work was by the representatives of the party, representatives to the parties. And this is the 197th nation, right? And also that agreed to this, and observer states. Now, this was held in parallel groups and also plenary. So what happened here, this was basically two events at the same time. As observers, we really didn't get to see, much of how what you call the sausage is made, right? Part of that was also COVID precautions also limited what we could see. We could see some of the plenary sessions, which were quite interesting, and we'll get to that in a minute. Now, what was going on as observers in this pavilion area? Well, the one we were at was this Cryosphere Pavilion, which I mentioned was hosted by the International Cryosphere Climate Initiative, or the ICCI, our pavilion. And so we had these things set up about what was going to happen to like sea ice with a 1.5 degree warming or stronger warming. There were several of these things set up, like polar oceans, ice sheets. A number of NSIDC people contribute to putting this together, especially Twyla. Twyla did a lot of work on this. And then there were almost, there were a whole series of talks that we would give at this pavilion. So you see various seats there. People would come in for one talk, leave out from another one, things like that. And this is one, I'm not sure who was giving this one. It's Jackie, no, I forget. Okay, in any case, not important. But that was one of them. Here's another shot of the Cryosphere Pavilion, right? So you have this set up on polar oceans and acidification, warming and freshening, ice sheets and sea level rise. Today, we're at 1.2 degrees sea warming, right? As I mentioned already, we're already close to at 1.5. What would be happening to glaciers and snow, Arctic sea ice, and permafrost, Of course, permafrost, as anyone at NSIDC knows, is a very, very important part of our cryosphere, and that permafrost is warming, and in some places it is thawing. There I am giving a talk on, well, this is on ocean transport. It was kind of odd, a little haphazard, in that we would receive notification that, well, Mark or Tuvalu or Walt, we'd like to have you give a talk on something. And it might not have been what we had planned. Right? It was very impromptu. And then might not have been our specialty. So what we learned quickly is that all of us, Tuvalu, myself, Walt, other people there, have given numerous talks on all kinds of different topics. And so we had all those old PowerPoints. So we learned quickly that what we would have to do sometimes is cobble together a talk in 2 hours and give it in an impromptu way. So there I am giving one on ocean heat transport into the Arctic. Interesting, you see everyone's got those headsets because what was happening is that there were all these pavilions all around, people talking, and of course you couldn't hear anything. And so what happened is only the speaker would be speaking into a microphone. Everyone else had headsets that they would listen in on. That's how they did it, because it was a constant din of humanity. Other events, singing at the Cryosphere Pavilion. Here's Arctic Indigenous Evening Gathering. They're throat singing. It's a very interesting thing to hear, this throat singing. And so there you see some narwhal in the background with like the tusks, which is actually an elongated tooth, as I understand it. So throat singing. Now, there were all these other pavilions. I mean, just the whole place was pavilion after pavilion. Here's the Tuvalu Pavilion. Now, as you may know, Tuvalu is this very small island nation, barely above sea level, which is in danger of being enveloped by a rising ocean. And so, of course, they have concerns about climate change, as you would imagine. So the big thing at their pavilion was these polar bears standing on the iconic image of polar bears standing on a melting ice floe. But here, of course, the polar bears in their life jackets. I didn't quite understand, as the polar bears appear to be smiling, but maybe they just naturally do that. But this was what the Tuvalu Pavilion had, or what it featured. Other pavilions, here's pavilions from Pakistan and from Korea, right? These are among those 197 nations that are representative. And so they would have different features, different things that they would be introducing or highlighting, including their efforts at combating climate change through greenhouse gas emissions, things like that. So they all had different interests and things like that. But here we have Pakistan and Korea. Now here's the United States Pavilion. Walt Meier took this photograph, and it was an interesting one because it actually has politicians, right? Senator Bob Casey from Pennsylvania, Dick Durbin from Illinois, Ben Cardin from Maryland, Sheldon Whitehouse from Rhode Island, and Mark Heinrich from New Mexico, all listening into a presentation, right? And they've got all their headphones, right? And of course, everyone had to wear masks, right? That was required. It looks like Senator Cardin is not doing so, so I don't know what was going on there. Here's Ghana, right? Here's the Ghana Pavilion. And what I found interesting with all these pavilions is when you walk around, you would probably hear 30 different languages, just from all over the world, 30 different languages being spoken. And in terms of the people, there were business types wearing suits and ties, along with a lot of people just wearing their traditional dress and things like that. Beautiful stuff, just absolutely beautiful. But you really got walking around, you got this impression. I mean, you really saw this cross section of people from all over the world. All there for a common cause, but it was just fascinating to see that cross section of humanity. Now, here's another one at the pavilions. Okay, so here, I'm not sure what country this is from, but this is dealing with challenges in the Amazon, right? Deforestation and things like that. You see there in the background, "Make Our Planet Great Again." Obviously, a bit of a response to the MAGA, make America great again. So there we are here at one of the pavilions. Now, other things. Politicians. Walt Meier cited John Kerry. Cited him going up the stairs, and before that, on the bottom left, you can see there he is with his mask. I didn't know he wore glasses, but I guess for reading, but there he is, and going up one of the stairs. So Walt got the great John Kerry sighting. We missed Biden's speech. Biden was there. There he is taking off his mask to speak, right? But we missed that speech, or I did. I'm not sure if Walt or Twyla did see it. I didn't, unfortunately. But Boris Johnson and other world leaders also made appearances at COP26. So we had these world leaders coming in, as well as the delegates and things like that, and all these observers. Another thing there, Walt took this one, tracking numbers, right, about what's happening, in real time, in terms of the total CO2 emission and how it's changing and how temperature is changing. So this was November 2 to November 6 that we went from 1.23746, whatever, above average, to a little 1.237, right, through the day. So these sort of near real-time numbers coming in. Other pavilions, right? Here was a pavilion that was kind of put a group that making really into bamboo, right? And here's their bamboo bicycle, except the tires, and it looks like the front fork doesn't look like bamboo to me either. So except the tires, and it looks like the rims are not either. Well, in any case, really pushing bamboo as this, renewable resource that you can build all these things from bamboo. Now, here's an interesting one. I started to call them the nuclear family. This was a group of a pro-nuclear group, a nuclear power group. These were mostly young scientists as well as students. And so here they are, all with their shirts, right, and trying to get across the great advantages of nuclear power. Now, I hung around with them a bit because I have very, very strong interest in the nuclear industry, nuclear power, and anything like that. So I was always peppering them with questions about reactor design and this kind of thing, and they were always more than happy to answer my questions. Now, one of the things they were doing to get attention was peddling radioactive bananas. As it turns out, as some of you may know, bananas are slightly radioactive. They contain potassium-40, which undergoes beta decay. Two types of beta decay, but the most common one is a beta decay to calcium-40. Right? So what happens is a neutron emits a high energy electron, right, and goes to calcium-40, which is actually one off an atomic number with energy release. Okay, in any case. But they were doing this to demonstrate, or to try to get the idea across, that radiation is all around us. There's background radiation and things like this, and this is just something that we accept just as living humans. Now, I had several of these bananas every day for breakfast. It was a hassle trying to find breakfast or something to eat around these places because it was so crowded. So I just went down to the nuclear family and got a few bananas every day. No ill effects, at least so far. Also, one of the things that was being handed out was things like 1.5 degrees Celsius chocolate bars. Not everyone got one. I got there at a lucky time when they were just opening up the boxes, so I was able to grab a couple of them. There's actually very good chocolate. I'm not sure where it was from, but it says store below 1.5 degrees C to avoid a meltdown. Check inside for more information. I should have just, at least kept the wrapper or something like that as a collector's item, but I was hungry, so I ate the chocolate. Okay? It was very good chocolate. I think Walt lamented that he didn't get any of this. He didn't see any of the 1.5 degrees C chocolate, but there were all kinds of things like this that you could get. Art on the sidelines. A lot of art. getting across issues of themes of climate change, or just welcome to Glasgow, right? Because this is a big, big, big event for Glasgow. There was a place where people would post cartoons and all kinds of things like that. So here's just some of the art that you'd walk by, either when you were going to the conference center or within the conference center. Lots of very, very interesting art. But protests, right? As you'd expect, a lot of protests. Protests inside the venue. As I understood it, there were designated times where people could protest. This was understood. There'd be designated times and places where this was allowed. So here's one: climate justice means gender justice. Here's another one on the bottom left. I'm not sure exactly what this protest was about, but this is just another one. But there are these protests inside the venue, but also protests outside the venue, as you could well imagine. So here we have one on the left here. Here's another polar bear. This one has a bit of a frown on its face. Something on the bottom right there: I march for snow, as I think we all do at NSIDC. We have that love of snow and ice, and so I think some of us might fit in there, right? And here's another one on the top right: no more fossil fuels. Well, that's a noble goal. Whether that's achievable is another matter, right? But lots of protests outside the venue and certainly in the streets. This is a photograph I took while I was trying to walk back to that horrible youth hostel. I forget what time it was, but it'd get dark pretty early in Glasgow at that time of year. But yeah, just crimes against humanity. That's quite a bold statement, but here we have a lot of protesters walking down the street peacefully. And it was just a sea of humanity. Now, there were also kinds of protests and gatherings even before the event started. And so here's one of them. I didn't take any of this. Is sort of Getty images, but it just shows you the sea of humanity and the people protesting and making their voices heard about the issues of climate change. So the delegates. Remember, I mentioned that there's the observers, like we were, me and Walt and Twyla, and the delegates. We did get to go to some of the plenary sessions. And so here you see this huge, huge, huge room where there's a bunch of delegates from different countries and their staffers. And they had been meeting in private groups or in parallel sessions. But here we are in plenary, where there's a lot of discussion going on about any agreements that were reached, things like that. The mucky mucks, the big, mucky mucks, were at the front there in the center at those seats. And they had a bunch of big screens, right, so that you could see what was going on. But you could tell this is absolutely huge room. So they had to get the sound system all set up. It was interesting on one side, right, were all these booths for to do the translations, right? Because there were all these different countries with all these different languages, and the proceedings were held in English, but then you needed translation services. So it's fascinating just to see how that worked as well. Now, here's the COP president. COP has a president, the COP26 president. He's on the big screen here, Alok Sharma. And I listened to him speak, and he was just a consummate diplomat. If you're a diplomat, you have to be very careful in what you say, how you say it, the wording, how to scold in a nice way. I've learned a lot by listening to someone like this. The absolute consummate diplomat, this guy, Alok Sharma. Now, so here's what happened. Right? So was it a success or a failure, this COP26? Well, it was a mixed bag, I think. I think that's really, well, depending on who you ask, it was partly a success, not really a success, or it was an abject failure. I'll get to that in a minute. So some advances were made. Something called the Paris Rule Book was put together, and that covers, let's say, transparency and consistency of reporting, common time frames, and carbon trading. So what this does is it enables assessments and measures of success and failure in mitigating climate change down to national and subnational scale, right? So assessments and measures of success, like, am I reducing my carbon emissions? Or what am I doing to address deforestation? Anything like that. and also agreement on how emission reductions can be traded at national and subnational levels. So there's this carbon trading idea, and I don't really know how that works. Okay? Maybe Tuvalu or Walt know more how it works. But there were issues to address, like double counting loopholes, right? It seems that we find that even in something like this, humanity does not always work in the most honest way, right? So there were these loopholes and things like this that were addressed. Another issue that was addressed was financing, because we have, of course, rich Western nations, and we have more developing nations that don't have a lot of money. And so that means there has to be some financing here to be able to mitigate climate change emissions, things like that, to really give assistance to the less developed countries that don't have a lot of money. And by the way, probably have the least to do with climate change, but are those who are going to be most strongly affected by it. So there were some successes there. But was there a great leap forward towards limiting warming to 1.5 degrees C? And I think very much the answer is no. Now, this is just my view. Right? Others may have a different view. But that certainly my view is that there was no great leap forward. Now, of course, we have to listen to what Greta Thunberg is saying, right? And of course, you all know Greta, a very strong activist. And she was there for a while, I guess, but from a BBC interview, she was not very positive. She said it's sort of turning into a greenwash campaign, a PR campaign for business leaders and politicians. She was saying, since we're so far away from what we actually need, she thinks it would be considered a success if we just realized what a failure it was. And so she summed it up from what she was hearing from the politicians and business leaders as more blah, 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 right? She does not mince words, like her or not, right? She's still a force out there. So Greta was definitely on the side of, well, nothing really happened, right? So it was a very interesting conference. But what I'd like to do now, kind of to end this, is just kind of look at these choices that we are facing as we move down the road. Here's just another shot of this action center that we were at. So, of course, here's the problem. The basic problem is this, is the carbon dioxide increase due to fossil fuel burn. And that is that our fingerprints are all over that. You can look at it from isotopic compositions of the carbon dioxide, all kinds of things. In any case, back in 1958, when this first started to be monitored at the Mauna Loa Observatory, we were around 315 parts per million. Now we're something at 415, 420. You can see these ups and downs from through the years. That's basically the planet breathing. Most of the land is in the northern hemisphere, and in the northern hemisphere, spring and summer comes in. Of course, there's more photosynthesis, which is sequestering carbon. And so carbon dioxide levels go down. There's net primary production, is what I can say more clearly, I believe. But then in the autumn and winter, right, that carbon dioxide, some of it's released back into the atmosphere. So there's that natural ups and downs through the year. But then there's this overall increase, and that is us. So what about this carbon dioxide, of course? That's the concern. And, you know, I don't want to get too much into the physics here, but this is, from my point of view, the most important kind of figure you can look at. And this is looking at the emission of long-wave radiation by the Earth to space, which we actually measure by satellites. And we also can model it very, very cleanly. In other words, we compare it to the observations, and they're spot on. This is from a NASA analysis, and it's looking at this emission to space from various places, like in the tropics, mid-latitude in summer, subarctic in summer, mid-latitude in winter. Now, if you look at this, like the one at the top here, if you look at it this way, there's this smooth curve, right? That would be what we call the Planck function. And that would be what we would see the emission if the Earth was just a black body, what we call a black body. But what you see instead is that there's these chunks taken out. Some of them are just narrow little chunks taken out, and those are associated with absorption by water vapor, which is the most abundant greenhouse gas in the atmosphere. by CH4. Okay, that's of course methane, another important greenhouse gas. More water vapor out here. There's an ozone feature, an absorption feature. But here's the thing, this ditch, they call it. That's the carbon dioxide ditch. It corresponds, it's centered on a wavelength of about 15 micrometers. It's given here in wave numbers, like 667 wave number, but think of it in wavelength, about 15 micrometers. That's the primary absorption feature of carbon dioxide. Now you see it's spread out. It's not right on 15 micrometers because it's what we call broadening, especially what we call pressure broadening. But what this is telling us simply, okay, is that there's this big ditch. And what this ditch is telling us is that carbon dioxide is absorbing long-wave radiation emitted from the surface. And the emission to space is only from the very high levels in the atmosphere, where the atmosphere is diffuse enough for the radiation to escape into space and where it's colder higher in the atmosphere. So if you don't believe that carbon dioxide is a greenhouse gas, you've got to explain this, and that's pretty darn hard. But what's happening here is that that ditch starts to get wider as we increase the carbon dioxide level. Now, there's other figures I could show here to look at this, but this, from the viewpoint of like a climate scientist, you've got to look at figures like this. It tells you exactly what carbon dioxide is doing for us. Of course, we're not saying carbon dioxide is bad, right? We have a natural greenhouse effect. Carbon dioxide is good, right? It absorbs long-wave radiation, makes it warm. We're about 30 degrees C warmer at the surface of the Earth than we would be without these greenhouse gases in the atmosphere. But it's always the issue of too much of a good thing, right? Now, the thing is, there's also feedbacks in the system that we have to be cognizant of. Water vapor feedback. That water vapor is a greenhouse gas. So the idea is we warm things up by carbon dioxide a little bit, but that means the atmosphere can hold more water vapor because the amount of water vapor the atmosphere can hold depends on the temperature itself. We warm it up a little bit, now more water vapor in the atmosphere, but water vapor is a greenhouse gas, so it makes it even warmer. The well-known water vapor feedback. Ice-albedo feedback, the one that we're very familiar with, many of us here at NSIDC. We warm things up a little bit, but now we melt some of that bright snow and ice cover, which of course we find a lot of, in the Arctic and Antarctic. And so now we lower the albedo, the reflectivity, because we expose the darker surfaces underneath. And that means we absorb more radiation, and that means that we warm it up further. So just some of the basic physics here. All right, and where we expect to go in the future from climate models. This is based on some earlier climate models, but the new ones haven't really changed the picture, is that this is what we're looking at by the decade 2020 to 2029 from what we call a modest emissions scenario, a modest greenhouse gas emissions scenario, compared to the track we're on, which is pretty aggressive, kind of a burn, baby, burn scenario. And this is where we are in 2099. Now you see here already projected, which we already see in the observations, what we call Arctic amplification. The Arctic is warming up at a faster rate than the rest of the globe. It was long projected to occur even decades ago. People were talking about, even the late 19th century, this is being talked about. We see it in the observations, and we project that Arctic amplification is going to increase. Part of that relates to the decline or the loss of the sea ice cover. But that's the future that we would be looking at. But as I said, we're closing in on that 1.5 degree C warming. We're around 1.2, something like this, right? Can we limit it to 1.5? Or can we limit it to 2 degrees C, right? In a sense, we're kind of locked in for some warming because there's already what we call heat in the pipeline. So we're going to have to live with some warming, but can we keep it to a level that we can manage? But what I'd like to just end this with is looking at the scale of the problem that we're trying to deal with. This is a satellite image, or it's a composite of Europe at night. You've probably seen similar figures like this for the United States, but this is just looking down at Europe at night. And you look at all the lights and you say, my gosh, how are we going to deal with that? How are we going to deal with these immense power requirements? Well, It's a big challenge. Let's look first at annual carbon dioxide emissions. Now, this is in 2019. I couldn't find a more recent figure. I don't think the numbers have changed that much since then. But if you look right now, China is actually the biggest emitter, about 29%. The United States, about 14%, so only about half of that. You have other countries, India, Russia, the rest of the world is a fairly big chunk. But then we have all these other countries, Turkey, Australia, Brazil, Mexico. Right? But China right now is the biggest emitter. The United States is really the second in terms of single source. But people look at this, and it's really not necessarily the thing you want to look at, right? Because what's important is the cumulative emissions. And the issue here is that, as I think some of us know, carbon dioxide has what we call a very, very long residence time in the atmosphere. That is, when you put it up there, it's going to stay there for a very, very long time. So what you really want to be looking at is the cumulative emissions, because once you start adding those emissions, say over a century time scale, a lot of it's still there a century later. And if we look at those cumulative emissions in terms of megatons of CO2, there's the United States. We are the leader in that. Then China is about 13%. So you see the whole scenario, the whole kind of numbers kind of changes when you look at it this way. Russia, Germany, UK, Japan, and onward, right? So that's what it looks like. We are, the United States, in terms of cumulative emissions, leading the way. So it's a big problem. Right? How are we going to reduce this? Not just in the United States, of course, but elsewhere. Of course, hydrocarbons rule. That's the challenge we've got. There's no quick turnaround that I can see. This is looking at energy consumption. This is going through 2019. It's probably changed a little bit. We have the pandemic. But the story has not changed. What we see, of course, is that emission. I mean, this is primary energy consumption. So this is energy consumption. I mean, that's what it is in terawatt hours, right? A watt is a joule per second. Multiply that by time, and it's a total energy. Right? So this is energy use, and as you can see, of course, it's climbing quickly, right? But look at where it comes from. Traditional biomass. That's like burning wood, things like that. Here's coal out here in this gray. You move up. There's oil, right? There's natural gas, and then we go up here. Nuclear, a little bit. Renewables, a little bit, right? How do you turn this around? Not in terms of the challenges. Number one, energy use continues to increase. But if we want to do something like use renewables, how do we make that such a bigger fraction, right? How could we scale those things up to really put a dent in the emissions that are coming from the biomass burning, the coal, the oil, and the natural gas? It's one hell of a challenge. Where there's other challenges, of course, a very volatile oil market. Here's Brent crude, which I follow. Right now, Brent crude, that's an oil indicator. It's an index mark, and it refers to North Sea crude oil, which is what we call light sweet oil. Right now, it's about $110 a barrel, which is way up there. Of course, it's gone up greatly. There's been lots of supply and demand issues, right, going through the pandemic. And now, of course, there's the war in Russia and all that. So it's a volatile market. So now we're at 110. No wonder gasoline, of course, is very expensive, right? So that adds to the issues because it's very volatile. And of course, that's where geopolitics comes in, right? A lot of the oil is pumped by countries which are maybe a little questionable, right? So renewables are great. Renewables really are great. And I'm all for them. But the challenge with renewables is how could we scale that up? Oh, they can be very cost effective on a kilowatt hour basis, right? But how do you scale it up? It's a fairly low density source of energy where the immense amount of energy in a gallon of gasoline, right? Low entropy, high energy concentration. Renewables are great. But how do you deal with the base load, right? If you're going to get away from oil and natural gas to deal with this. And so maybe the university will dismiss me now if I say that I am very much pro-nuclear, very pro-nuclear at this point, because I see the advantages. If we go stronger nuclear, you wouldn't be dealing with pressurized water reactors like this. You'd be dealing with newer, modular, fast neutron is what they call them, designs, which are on the books. We can do. And I don't see how you can get around dealing with this massive baseload that that has to deal with this power in Europe without going to something like nuclear. So I'm a very much pragmatist. Right? What I say is pragmatism must be key, for nothing ever comes for free. Nothing comes for free. We've got to be pragmatic. We are warming up, and we're going to have to deal with some of that warming. We have to try and limit that warming before it gets out of hand. How do we limit that warming? Great, bring on the renewables. How do we deal with the immense power requirement, the base load? I think it's nuclear. Now, of course, others may disagree with that, but that is certainly my view. So with that, I will end, and I suspect there could be a few questions. Thank you.